Good afternoon, everyone, and thank you for joining us on today's webinar. My name is Lindsay Miles Pickup, and I am with our Partnerships and Outreach Unit at the Ministry of Agriculture. Today, we have with us Julie and Matthias and Sandra to speak about best practices for on-farm management of runoff, drainage, and erosion as it relates to agricultural practices in the Peace River region. The aim of this presentation is to help people develop a deeper understanding of how to influence and manage factors related to erosion and soil loss. So the webinar is made possible today through the Climate Action Initiative funding, and we're grateful for that, and the Peace River Agricultural Steering Committee. So great. But before we begin today, we wanted to go over a few housekeeping items so everyone knows how to interact. In the upper right-hand corner of your desktop, there is an attendee interface. The orange button with the arrow allows you to open and close your participation panel. If you have any questions today, type your questions into the questions pane of the control panel at any time during the presentation. We're going to be collecting these throughout the presentation, and there's quite a few question and answer times throughout the presentation, and we'll do our best to answer them then. If you have any additional questions at the end, if it comes to you after, we encourage you to reach out to the presenters, or if you'd like to speak to a ministry staff person, you can reach out to us through AgriService BC. And you'll also notice that there are a number of handouts available to you in the handout section of your panel there. So please feel free to download those and utilize them at your discretion. So before we launch in and I hand this over, we wanted to do just a quick poll to see what sectors everyone is affiliated with. So in a second, once I get this launched, you're going to see a poll that asks you that. So you can just click on the answer that's most appropriate for you, whether that's livestock, grain, oilseeds and pulses, forage seed, forages, or other. We'll just give everyone a minute there. So we've got about 75% of everyone voted. So right now it looks like we've got 33% of individuals are involved with livestock, 11% with grains, 22% with forage seed, 44% with forages, and 56% are other. That's great. So I'm going to hand this over to Matthias and Julie and Sandra. I'm going to mute myself, but I look forward to chatting with everyone else throughout the presentation.
Awesome. Okay, everybody can hear me? Or, well, I wouldn't know. Okay, welcome to this webinar tonight, this afternoon here. Just want to briefly introduce the project and our presenters here. I'm the baby in our team. I'm a professional agrologist. I'm a certified professional in erosion and sediment control. Been working in the Peace for a little over 10 years in both the agricultural and industrial settings. And my role in this particular project was largely focused on mapping, remote sensing, and some field work as well. Also would like to introduce Julie with me here, my colleague there, who has been working in the Peace for over 20 years now. She's also running a cow-calf operation in the Peace, and really in this project she's really getting into her passion, which is related to plants and how they relate to soil and interact with soil and erosion. On the other hand, I have Sandra Burton with me, who will also presenting today and will play a really important role in our project here. Sandy is a private consultant in the agricultural sector who has, I think, over 30 years of experience now and in the Peace, and her passion is really related to soil health, organic matter, how that all interacts with landscape dynamics. I will briefly talk about how this project came about. I'm going to leave the webcam on for a little bit. I'll probably shut it off later that you don't have to look at me the whole time. So the project objective, this is a project that was made possible by the Climate Action Initiative. And it was focused largely to figure out what is happening right now in the piece, the current extent and the nature of the erosion, drainage, and runoff issues and practices that are in use. Come up with a bit of a summary for that, identify potential management practices that could help us manage some of the risks that we're exposed to, and finally transfer some of that information to producers and to the people that can actually apply it and can make a change, which is part of what we're doing right now. Oh yeah. So to get us going into in this discussion, we're just going to play a brief video here.
Water erosion begins with the force of each individual raindrop. Raindrops may seem insignificant, but they strike the ground with amazing force. Rain can pound the ground at speed of up to 30 miles per hour. An intense storm of bare soil can loosen and detach up to 100 tons of soil per acre. When raindrops strike bare soil, they dislodge soil particles and can splash them as far as 3 to 5 feet away. This process is greatly exaggerated on a downhill slope. As soil particles are dislodged, they can fill in or plug surface pores in the soil. This prevents water from infiltrating into the ground. Instead of soaking into the ground, the water carries soil particles across the surface, creating runoff and erosion. Water erosion can be classified in 5 different types: sheet, rill, ephemeral, gully, and stream bank. Sheet erosion is a subtle type of erosion that can be very damaging over time. It involves the loss of thin, uniform layers of topsoil over the entire field. Soil loss can go almost unnoticed until many years have passed and the subsoil is exposed. By the time you notice the loss, the damage is already done. Rill erosion is easily identified as a series of little channels or rills that cut into bare soil. These channels occur on slopes and are small enough that they can be removed by normal tillage. Rill erosion cannot be predicted and will occur randomly anywhere across a hill slope. The third type of water erosion is ephemeral. This differs from rill erosion in that it usually will form in the same location year after year. It develops in natural depressions where there is a concentrated flow of water. Like rill erosion, it can usually be erased by normal tillage methods. Gully erosion forms channels that are too large to be erased by ordinary tillage. When left unchecked, the top of a gully, called the head, will continue to cut upslope. Head cut development and gully erosion seriously threaten soil resources and the sustainability of farmlands. Deep, wide gullies severely limit the use of land, making it impossible for farm machinery to cross. The final type of water erosion is stream bank erosion. This process is caused by the continuous flow of water through a channel, which cuts away the stream bank. It is generally a slow process, but can speed up dramatically during floods or heavy rainstorms. Stream bank erosion may change the course of a river or creek and causes severe erosion in that specific area.
Perfect. I think we're going to stop it right there, because so that was a pretty good intro. The problem with erosion, and if you're trying to understand and address soil erosion at a landscape level, we need to figure out what factors cause the loss of soil and what practices are available that help these to reduce these losses. So that's been a problem for a very long time, probably starting in the US with the Dust Bowl issues. There we go. And ultimately led to the US Department of Agriculture doing a whole bunch of research at field scales and coming up with what's called the universal soil loss equation. That was first released in 1965 and is aiming at predicting long-term average soil losses through sheet and rill erosion at a fairly small scale. So as I mentioned, that was developed in the eastern USA, and it was exported. Everybody was trying to use it somewhere else, and it didn't really quite work, especially in Canadian conditions. So the Agriculture Canada's research brand developed what's called the revised Universal Soil Loss Equation for adoption in Canada and released it in 1985. That is to this day the formula that we utilize if we're trying to figure out what factors affect our soil loss and what practices can we use to mitigate those losses. In the 80s, during that research project, it was estimated that just the replacement cost for agricultural operations related to erosion was somewhere in the range of $6 to $12 an acre, which is, I mean, the input costs have increased since. It's probably, we have implemented some good conservation practices to reduce erosion, but there's still significant cost associated with that today. So this revised universal soil loss equation considers 5 factors that we will probably take apart, or not probably, we will take them apart and explain them a little more throughout this presentation. It considers rainfall and runoff, rainfall, erosivity, and runoff, the soil erodibility, the inherent erodibility of the substrate, the slope and topographic conditions, and what crop management and vegetation factors apply, and any kind of support practices that we can implement to mitigate erosion. Just want to direct your attention to that short video. There's no sound or anything associated with this one, but you can see there's a little bit of rainfall and it dislodges quite a few soil particles. There's a lot of kinetic energy that's transferred to the soil through the raindrop. If we increase, or well, if we experience increased precipitation or just a more higher peak intensities of those rainfall events, the energy transfer to the ground increases exponentially. So this R factor that we're looking at a landscape level was mapped out in the 80s originally here. This is an example of rainfall erosivity factor map for British Columbia. You can see Fort St. John in the northeast, we're right in that 500 range. If you look at Vancouver Island, significantly higher rainfall erosivity, primarily just because of the higher rainfall amount. I want to point out that this research work was done in the 80s. If we would do it again today, we would probably get slightly different values under the current climate change models. If we're going 20, 30 years ahead, we're probably going to see a completely different scenario again, which is part of the reason why we're looking at these kind of issues right now. Just a quick summary for rainfall and runoff. The rainfall erosivity, we don't really have any direct influence on those raindrops. It's kind of a static factor across the landscape. Doesn't matter if you're in Fort St. John or 50 kilometers out in a different area, you're always going to have the same kind of factors associated with the rainfall erosivity. What we can do though is we can work on intercepting the rainfall or the raindrops, and we can work on reducing the impact energy that's transferred to the soil. Just going to transfer, or I'm going to let Sandy talk about the next factor a little bit here.
So the next factor that's part of the universal soil loss equation, or the revised universal soil loss equation, is the K factor, or soil erodibility. We're mainly, of all the things we could talk about, we're mainly going to focus on 5 important properties here: texture, structure, organic matter, aggregates, and infiltration. And some of these we have more influence over than others. So texture is the particle size. It's mainly related to whether the particles are very, very small, as in clay-sized particles, medium-sized silt, or the coarser sized particles of sand. And the smaller the particle, the more easily it's moved. But clays do not occur naturally as single clay-sized particles. They're often as aggregates, so it means that the silts are the most erodible. And silts in the topsoil and subsoil are very common in the Peace region. The next property is soil structure, and soil structure is all about the stories the soil is trying to tell you about how it was derived, how it was deposited in the landscape from from the glaciers, how it's the processes that are happening down through the profile. So it gives you glimpses, but you really don't have much control over it. Sorry, glimpses and insights into how it got there and the processes, but not something you can change easily. But the third property, organic matter, can be changed. And Julie will talk about this more later, but there was moving on from the research that Matthias was talking about into the later 80s, early 90s. There was research done in this region finding that conservation tillage can increase organic matter as much as 2% in 9 years. It was happening sooner than we thought. And now we're also finding this in these times with managed rotational, or the current term is regenerative grazing. We're making incredible leaps of improved soil quality and organic matter, and winter feeding or bale grazing type practices. So winter feeding practices like bale grazing, we found with repeated looks at detailed case studies here that we are improving organic matter, pH, topsoil depth, infiltration, and soil respiration. So the soil profile or the spadeful shown on the right-hand side is before some winter feeding practices, and then with just 2 or 3 years, we can get to the soil on the left-hand side. And with working with Dr. Bill McGill at UNBC, they've taken a lot of detailed slices of the soil. And so here you can see that organic matter and how it's integrating with the particle size and the pore space in white, or the pore space is filled with water. The fourth factor is aggregates, and what we want are the healthy aggregates like on the right-hand side. Again, another a magnified version of what's happening in the soil, with an aggregate in the center, which is a combination of the organic matter interacting with the particles, and you see the dark pore space around it, and that's kind of a healthy soil. Whereas on the left-hand side, you can see what happens when that starts to break down and there's no more pore space, so that you've got crusting happening on the surface. And so there is some ways that this can be managed that will be talked about in more detail later on in the presentation. Aggregation interacts with, as I mentioned, soil organic matter, texture, the microbes. It lowers the bulk density. There's an interaction with root penetration, improved aeration, and improved infiltration. So these factors are all integrated. They're not single isolated factors. So now leading into the fifth factor that can be managed, infiltration. How fast is that runoff or rainfall able to get into the soil? And this can be managed by increasing the soil organic matter, soil cover, being very cognizant of when farming practices are done so that you're not creating ponding or crusting, and careful timing of practices. So the key message here is that organic matter matters. If you want to only focus on one soil property and keep it simple, organic matter matters, and it has incredible spin-off results. And once there's healthy aggregation, there's healthy roots, there's healthy plants, and you can see the two pictures on the right showing the comparison between good aggregation versus poor. So in summary, we can't really change texture and structure. We can get insights into how erosive the landscapes are. It does matter where you are in the landscape, and that has an effect on texture and structure. What we can improve are organic matter, infiltration, and aggregates. Sorry. So the next factor is the length of slope and steepness. Steepness of slopes obviously adds to the risk. And so here's a table where you can see that the steeper the slope, the more you move across to the right-hand side of the table, and the more erodible that slope is. But in the Peace region, we need to realize that the length of slope adds more risk. So if you take a 2.5% slope, which is considered nearly level to very gently sloping, with only 100 meters of length, you can see where that comes out in this table as the least erodible slopes. But when you have 100 meters of length, and there are many fields in the Peace with those long slopes that go on for a quarter to a half a mile in that 600 to 1,000 meter range. And you can see how that very gentle slope is now highly erodible. We can also look at this at a landscape level. And so during this project, we took the Saskatoon Creek watershed north of Dawson Creek as one example of any watershed we could have picked to look at this in a spatial way over the landscape. And we're lucky in this area, we have very well done soil maps that were done. And we can look at these soil maps and look at cross sections and start understanding how the LS or topographic factors and the K or soil erodibility factors interact with the landscape in a spatial way. I'm going to try this. So looking at this cross section from west or the higher part of the watershed down to the eastern or lower part of the watershed, here we have that cross section here. So you can see to the east where we have these flatter lacustrine lake deposits, and then where the morainal lumpy parts of the landscape, the melting of the glaciers. So these are these slopes that can be 5 to 9% versus these slopes. Now these slopes in Escher country, so in these areas, they may seem very gentle, but if they go on for those, quarter to half mile, and this could be any watershed in the Peace, this could be around Montney, this could be out in any number of watersheds, you'd get this same pattern that the soil maps help you understand. So in summary, we can't easily change the factors. We can't change the length and the steepness of the slope. It does matter where we are in the map, the landscape and the watershed, whether we're in the top or the upper, middle, or bottom. We can use soil erosion and sediment control measures or create speed bumps. But again, I'm going to leave that for Julie. And are there any questions at this time? Now, we
pull the camera up?
Yeah.
So if you have any, some feedback. This isn't going to work. I apologize. If you have any questions, please feel free to send them to us through your chat or the questions function on the panel page there. But in the meantime, I have a few questions. So when you were talking about rainfall and runoff, would you be able to talk a little bit more about how winter feeding affects runoff?
That's probably best answered by you. Winter feeding?
Sure, so I can try and answer that. So the winter feeding is a practice where you're improving the organic matter, you're improving the infiltration, and so the energy from the rainfall or runoff is entering into the soil. Anybody want to add anything?
Yeah, I think the other thing that winter feeding can do is it can provide some armor and protection for your soil as well, so that those raindrops aren't hitting the bare soil, they're hitting plant material as they go to infiltrate into those pore spaces.
Great. And if folks wanted to increase that organic soil matter, how would they go about doing that?
Well, that is definitely a Sandra Burton question. As we go through that, Lindsay, if you want to throw that poll up at some point during this too, they can answer the poll while Sandy maybe is giving an answer to that question.
Absolutely.
Thank you.
So increasing soil organic matter, as I said, reducing tillage, that's definitely one way. Improved grazing practices that we're seeing, more managed grazing, rotational grazing, whatever the current term that you're using. We talked about winter feeding practices. I didn't mention the perennial crops, the forage seed crops. We know many instances of where the grass, the perennial grasses, all that root system is improving our very fragile gray luvisols. And yeah, we've worked with farmers documenting that as well. Anything else that I've?
No, that sounds good. It looks like we've got about 50% of folks voted. For those who are online, we do have a poll up right now. Just trying to get an understanding of what soil erodibility component is of most concern to you, so that our presenters can maybe speak a little bit more to those areas. So we have about 58% of folks voting, and it looks like seasonal runoff is sort of leading the way here in terms of what's of most concern, followed by infiltration of water and compaction of soils, with organic matter soils being a little bit lower down. Maybe we'll leave this open for just another second and see if anyone else has some thoughts. Oh, that makes all the difference very quickly. It appears that most people are sort of pretty balanced when it comes to the infiltration of water and compaction of soils and that seasonal runoff. So perhaps we could talk a little bit more about what that means and how that could be addressed.
Sure, that's a perfect link into, I think, some of the pieces that I'm going to cover in the next portion of this talk, Lindsay. So I think I'll just segue into those pieces and explain how those factors tie in. I'm not surprised to hear from the group that spring runoff basically is our biggest concern, because we're having these freeze-thaw events. I mean, we're going through it right now where we've had 3 springs so far, and we're in the middle of winter again. So definitely a challenge for us. So I think I will is our camera still on, Matthias, or?
No, your camera is off this time.
Yeah, sorry, I got to figure it out now. Okay, so the factor that one of the factors I get to talk about is the crop vegetation and management component. And so there's quite a bit going on in this factor that reflects the effectiveness of the soil and the crop management system to prevent soil loss. So this is usually the stuff that resonates with people who are out managing on the soil base, because it's a lot of the things of what we can do to improve the situations that Matthias and Sandra just went through. So specifically, when we look at these pieces, we would be looking at things like crop canopy or surface cover, where those are the pieces that would help manage rainfall and runoff and erosion factors. So crop canopy would be things like having living plants. That's the living plants. You can see in the diagram the rain's hitting them, intercepting it before it hits the soil, versus as you move along that diagram, how you get into bare soil and now there's no intercept and the erosion risk is higher in those scenarios. The surface cover component is things like leaving stubble. It's referring to dead plant material specifically. So it can be winter feeding as well, like we were talking about earlier, protecting from that raindrop coming in. Anything that you can really think of like an armor or shield over top of the soil to prevent direct impact of that raindrop. So another variable in the crop and vegetation management component is soil biomass. And so soil biomass is more about the plant material or organic material, not organic matter necessarily, that's in the soil. So this is talking about how well we've been able to integrate plant material into the soil. So generally speaking, having a bit of plant material into that soil adds pore space and opportunities, basically feed for microbes in those pieces, and helps build stability. Obviously, if you get that material integrated into the soil by extreme disruption like disking or intensive pugging from cattle, it's not necessarily always going to be a stabilizing effect. So this mostly affects the soil erodibility factor Sandy was talking about with organic matter and aggregate stability. Moving over to the tillage component of this slide is the key thing with tillage as it affects erosion is right time, right place, right frequency. We can't emphasize that enough in our region with our vulnerable soils. So one of the cool things that's happening in the last 5 years in our region is the use of things like the high-speed disc that's illustrated in the picture above. So for perennial farmers especially, this is a great tool where you can go in and in single pass disturb a site for rejuvenation process, really narrowing your window. So, you know, maybe you don't have to do fall tillage, creating a whole bunch of vulnerability of soil loss. You can get away with doing just spring passes in the high-speed tillage tool, and that would allow you just to have a short window of exposed land before you're able to reseed into it and move into the next piece. There are lots of other factors that play into that other than just high-speed tillage. Conservation tillage is another good one. You know, rotational grazing and how you manage your hay stands in terms of longer hay stands also play into it. So not tilling, if and when that's possible and appropriate. So this factor mitigates rainfall and runoff erosion. If we're doing less tillage, there's more intercept opportunity. Tillage, if you till too frequently, you can have basically powderized soil, especially if you're in the Farmington area. You can really relate to that term of just that puffy powder soil that disappears if you work it one too many times, or at all, as some of you would say. The length of slope factor is impacted because if you're tilling on slope, the erosion factor Sandy was talking about goes way up. Oops, I think I'm sorry. So another variable in this factor is surface roughness. So that's really what condition you're leaving that soil surface in. So, you know, right after we seed, a lot of us have a really flat, we've packed it, it's smooth, it's bare in cases where you've been tilling. That's like super vulnerable. Picture a newborn baby time for your soil. So as much as we can do to minimize that window of how long it's this bare, flat, smooth soil is better for everyone. And that's where a lot of the minimum till implements are leaving them those little ridges on the soil. That's really helping with surface roughness. When we're doing a disc in the fall, only doing one pass so that we are not completely pulverizing that soil and it has some integrity to withstand the spring runoff that we were just talking about earlier. This is a real factor that deals with spring runoff and how to mitigate those erosion risks. Prior land use is another variable, and so I was kind of surprised. I guess I should have realized it when I was doing the research on this, was talking about, it wasn't just about what the specific stand was, but it was about the condition and the soil health that comes with that. And so the term that comes to mind is polycultures, and you know, for us layman type people, that means mixed stands. So that's a hayfield for most of us. If you have a hayfield, you have probably a more diverse biological system underneath your soil and a bit more integrity in the roots and structures than if someone is monoculture, monofarming. So if you're doing wheat in a rotation, which would be a monoculture, you will have just less diversity in the soil. So one of the things we can do is crop rotation to help with minimize these erosion risks. And that's a big factor for people in our region, especially because we struggle to have a lot of crop options. So a lot of the annual farmers on the phone call only have 5 crops, and maybe there's only really good returns on 2 or 3 of them, depending on their soil type and their climate. If they're up in the Presbyterian area, you know, they have some limitations with climate, so that eliminates a couple of those crops right there. So challenge for people, but I encourage them to continue. One of the things we really saw in this particular project was the opportunity around forage seed and perennial cropping. Is it really has a place in some of our more vulnerable soils in this region. And over the years, because of markets and a lot of reasons, we maybe have been annual farming some of the land that's really quite vulnerable. And over years, we're starting to see it eroding. And I just encourage people to think about perennial crops and how they might fit back into our rotations as a soil protection measure. So the last factor under crop management or crop and vegetation management is around distribution of erosive rainfall over the season. And so that's really about understanding when do we get the most intensive rain in our region. So you can see on the left-hand side of the screen, the Vancouver region is got a lot of their precipitation in the winter seasons of the year. And in the Peace, we're just about exactly the opposite. We get most of our precipitation in the summer seasons of the year. This is not a volume scale, but a relative scale. So this is about the percent of precipitation in these regions. And if you're in the Prince George area, you can see how it's fairly consistent. So this matters what you do with crop cover and when you're most vulnerable to crop cover. So in the Vancouver area island, I can see how perennial ryegrasses and winter cover crops and those types of conversations that a lot of us here have a great place for protecting that soil during those really vulnerable times. Those may not be the best tools for protecting our soil in all conditions because of when we're getting our vulnerability. There's certainly those perennial crops or cover crops have opportunity, but way less because of the climate conditions that we have. So I just want to emphasize, as Matthias had said, some of this data was collected a while ago. And so on the left is the data that came out of the RUSLE diagram, and it's a 10-year accumulation of rainfall in the Dawson Creek area. And on the right is Fort St. John 2019. And what you can see is that, you know, our relative amount of precipitation fell in the brown column is August in 2019. So for those of us who were here, we remember that it rained a little bit every day. If I had put up a slide for 2015, we would have seen the green and blue bars jump way up, and we got 12 inches in a 48-hour period. What we're seeing with climate change, the implications of that is much more extreme weather events in an unpredicted timeframes. So it's a lot harder to plan for soil cover and good plant vegetation if you don't know if you're going to get 12 inches of rain in June or if you're going to get 12 inches of rain in August. And so the important thing for us in our region is to start thinking about how do we get plants growing as quickly as possible. Things like that high-speed tillage that help you get through the rejuvenation process as quickly as possible. Things like the vertical tillage where you're able to maybe fluff up a little bit of the soil to get you on there faster, to get things growing so that we have green, live plant vegetative material intercepting those raindrops. When those big rain events come, plant cover, good soil organic matter, those are really critical factors for us in dealing with, say, 50% of the type of storms we get. In the next tool, or the next factor, I'll explain what happens when we get the 12 inches of rain at one moment, and that's a little bit more difficult to manage for us. So this last factor deals particularly with rainfall and runoff erosion. So in summary of that crop vegetation and management factor is it's easily influenced by management decisions. It's something like it's one thing we can control quite easily. We can make those decisions at the beginning of the season. It doesn't matter where in the landscape you are. If you're having a problem, a lot of these tools are available to you to address those issues, whether you're at the top of the slope or at the bottom. And the opportunities for conservation tillage, cover crops, residue management, winter feeding strategically in locations, these are all ways that we can help mitigate some of the earlier risks that we were talking about. So the last factor that we're going to go over during this webinar is the support practices. And so this reflects the practice that will reduce an amount and the rate of runoff by modifying flow patterns. So for those of us who were really interested in spring runoff discussions, this is the portion that is kind of addressing specifically that challenge in our region. So, you know, what does that mean for us? So some of the tools that we can do, or some of the variables that we can manage, is like cross slope farming. So instead of farming up and down your slopes where water has an opportunity to run down the channel of your tire tread or your seed drill, is going across those slopes. One of the challenges that happens for us in our region is, okay, that sounds great, Julie, but that slope is going north to south, and when I go to swath my canola or something, or any swath, you're going the wrong direction for the wind, and that's just not going to work in my operation. And I think that's one of the things that we've really seen develop in the last 10 years that we're utilizing more. I think it's been there for a while, but is the desiccating and using that as a tool to help prevent soil loss and erosion. Is I really see leaving standing crops when we can, and I do appreciate the winter we've just come through. So there's always restrictions with these weather events that we have, but leaving standing crops when we can on these very vulnerable landscapes. And so this isn't your whole farm, but if you've got particular fields that are really risky, or that you've done, maybe you had to do some tillage because you had bad ruts from last year's harvest, these are the places where maybe the next winter or wet next fall, you're leaving that crop standing as long as you can to have that protection in there, and then trying to straight cut combine those crops instead of swathing them and then having to deal with all these other variables. So I think there's lots there. It's sometimes challenging. It's easy to think of the reasons why I can't do this. It's a little bit more to put your brain to how could I make this work. Contour farming is something that we don't see a lot in our region per se. I think one of the challenges is the grass waterway concept. So I think for the forage seed producers who might be on this call or producing, they're utilizing this a little bit more because they are leaving a lot more grass waterways and they're on the slightly more marginal lands. For annual croppers, it means more corners, it means more challenges. Their big equipment doesn't fit through there. There's lots of challenges with that. But I would just go back to emphasizing that on landscapes where you have particular vulnerabilities, look at this as a tool for maybe a season or two until you build back some of the aggregate stability and the stability in that soil to protect itself against erosion. So maybe some fields need a contour farming break to help protect it and get everything back in place. Like think of it as a recovery program, and then once it's up and functioning, perhaps you can go back to a bit more conventional farming practices. And then if you see things start to slide in soil erosion again, maybe you're integrating that on a 5-year rotation, depending on what your vulnerability is. Same thought in my mind with strip cropping. Strip cropping is something we don't do in the Peace region, and I really think there is some opportunity in the high risk situation. So don't walk away from this thinking this girl's crazy, she thinks we should be strip cropping everywhere. It's more of a tool. I was talking to a producer through this project who's got a steep slope, and through a course of management things that have happened, they're starting to see sheet erosion on that landscape, and it's over a quarter section, they've got half a mile of steep slope, and it's been degrading rapidly in 5 years. Well, here's some tools maybe they can look at, 40-acre parcels, accommodating equipment size, but creating a perennial strip in there just to hold that soil a little bit until they can reduce that vulnerability. So in this image, they're showing like every seed row or every seed drill pass as a different crop, and I'm thinking in our landscape it might, we all might find it more palatable to think of it as chunks or acres, where I do a 60-acre chunk of a perennial on the side slope, and then I do my annual cropping that I'm more familiar with on the lower vulnerability slopes until I can get things stabilized. I'd heard a producer talking about seeding. What was he seeding? He was seeding wheat with perennial ryegrass underneath. And so not necessarily strip cropping concept, but providing that stability through a season on a vulnerable landscape. So they'd harvest the wheat crop this fall and harvest the perennial rye crop the next fall. And in that scenario, the perennial rye crop was of interest, ryegrass crop was of interest because it's a low risk for that producer. If they did winter kill, it's $8 an acre that they're out and they can go back to annual cropping. So some interesting concepts that could play about there, and it really addresses all of the erosion risk factors that were discussed earlier. So lots of opportunity to think about in how that might work. Terracing, we don't see a lot of that in our region. I just wanted to put it out there that, lots of times I hear, Julie, well, we can't farm that, it's too steep. And I just want to say, look what they do in China, man, anything is possible. So not where we're necessarily going today, but I think there is some landscapes that maybe would look like that. And that's really dealing with the length and steepness of slope issues. So in summary of those factors, those are really strategic long-term plans to implement. They're probably not on every piece of land you own. They're on particular challenging properties that you have that you might want to be thinking about those support practices. Landscape is really driving those decisions. It's usually on those mid slopes that Sandy was talking about. Maybe you only have a 2% slope, but if you've got 4 miles of it, this is maybe where some of those opportunities to break up what's happening. A lot of us tend to, great, I got 600 acres, I'll put wheat in the whole thing. And changing up how we think about it. So maybe we are strategically doing 160 acres of another crop inside of that. Even if it's an annual, just having like the canola, wheat canola strip in that large field helps with the integrity of that soil. So I think at this time we'll pause in presenting, throw the camera up, give an opportunity for questions, and I think there's a poll as well, Lindsay, that we can kind of do while questions happen, if that works.
Absolutely. So I'll throw the poll up right now. We do have a couple questions, but I'll just get the poll going while we ask those. So want to have an understanding of what practice do you see as the greatest potential to address your soil erosion concerns? So that's up on the screen if people want to participate in that. In the meantime, I just need to open this up a little bit easier. Can you have too much organic matter is one of the questions. So for example, can you have problems on the opposite end of the organic matter spectrum? Do you want to answer that one?
I'll give you a short answer, and if Sandra wants to add in, she certainly can, but not in that we're familiar with in this region. You know, our organic matter levels are often around 2 to 4%, and certainly you can get up into the 10 to 15% without seeing any negative implications. Having not seen a lot of soils in this region that are over 15%, I would say that would be challenging to get, but maybe Sandy has anything you want to add?
Where we do see high organic matter levels would be in low areas where we want as much absorbed, again, in as much as the landscape can take. But yeah, more typically we're seeing more like 1 to 2%, maybe the luckier people on those those better soils in the eastern part of our province might be getting up to 4 to 8%.
I think the only piece that I would add to that around there is when you're winter feeding or doing things to build soil organic matter, try to focus it in the areas that are lower in soil organic matter. So that's your hilltops and your ridges. So if you're winter feeding and doing those practices, I think that, you know, maybe you could get too much in those low areas, but only if you winter fed for 20 years down in the bottom of the hill in the valley. And so just recommending that you focus your soil improvement activities upslope from those potentially vulnerable areas. And I know like areas that have a lot of water table issues or water reservoirs handy can experience some of those challenges with adding organic matter, but it's not really a huge issue for our region. Any other questions?
We do. This one's a bit longer, so I'm going to do my best to try and get everything in here. I appreciate all of the effort that went into this question. So on the landscape level, when considering farms at the agri-forest interface, a major issue is the clearing and or modification of upstream first order drainages affecting the downstream of second and third of drainages, resulting in rill and gully and stream bank erosion. So given obviously limited of, I believe the word is I'm sorry, I apologize to that, to the agricultural landscape component, they're wondering about efforts to consider catchment approach, so extending P factor analysis for designing erosion management and prescription. So for example, restoration or mixed landscape strategies like agroforestry of upper reaches to reduce surface and channel flow velocities. And how are efforts in research being pursued right now to consider improved watershed management in the piece given climate change effects? If you're able to answer that, and if not, we can certainly readdress that back to the Ministry of Agriculture and try and get some answers there.
Great, thanks, Lindsay. I'll try and catch a few pieces of it. When this question started, I thought maybe Sandra's husband, Richard Kabzins, was writing a question, and now I'm wishing he was here to answer the question. I think one of the things about the vulnerability of those pieces is in this project, we didn't deal a lot with the sediment catching component, which I think is what they're alluding to a lot of, is when you're doing these practices, how do we do with catching sediment and managing that piece, which would often be happening in the lower part of the landscape. So from a large construction management perspective, I can't offer a lot of value to that piece. And like Lindsay said, we certainly can connect that person with people who can. In terms of on an agriculture basis, I mean, those are the really rich soils that we've been doing some of our horticulture practices on. And those are soils that the idea, I've heard the concept of like, let's harvest that soil and move it back up the soil bank. That's not the way it works. And so doing things like the strip farming to mitigate those practices are the things that come to my mind. In forestry, it's leaving areas that they haven't disturbed to catch that along the contours of the land. So I don't think I've probably addressed what they were hoping that we would say, but I think the big piece is slowing down that water flow so that we aren't getting all that sediment down to the bottom, loading it into the water course or wherever it's headed. In terms of I think the last part of that question, could you repeat like the last sentence that you read, Lindsay?
Absolutely. So how are efforts in research being pursued to consider improved watershed management in the Peace region given climate change effects?
Perfect. That reminds me. Okay, so within that, I think that's where projects like this came from. There's a steering committee of many of the agriculture groups. So they've identified that there are some challenges. We're working to, you know, pick high profile watersheds, which will be later in this slideshow to say these are where we're most vulnerable. In terms of some of the other industries, like they alluded to, the logging and the forestry component, there are research people like Sandra's husband, for example, who've been working on the long-term soil productivity type work. So there is stuff happening out there to address some of this, and I think we just keep supporting that and showing up and encouraging people that this is the reality, and it's going to be more extreme moving forward for us. So, anything else you'd like for us before we move on to our last segment of the webinar?
I think we can just go through the answers to that poll. So it looks like 50% of individuals see increasing soil organic matter as a practice that they use, 20% use increasing use of minimum tillage, and 20% have identified other.
Perfect, thank you.
Great.
Yeah, and I think to me the organic matter is one that a lot of people are doing, but not all of us have on our radar as an erosion or soil protection strategy. We often think about it as a source of nutrients and how to better get greater yield. It's also doing other functions for us about getting the water into the soil instead of running it off, and providing that structure for preventing erosion, etc. So it's I think a critical piece. So just in summary, we've gone through the RUSLE or RUSLE factors that are involved in assessing risk of soil erosion. So that's the rainfall and runoff, R, the soil erodibility, K, slope, the LS factor, so that's length and steepness, crop and vegetation management, and then the support practice management, P, that we just finished talking about. So when that work was done, it was, you know, North American wide researchers that were involved in pulling all those factors together to understand those risks. And so if you go to the later in this slide or the next slide, I think I provide the link of looking up the RUSLE, I think it's FAC, or it's the Canadian version of it anyways. And what they do is provide all of the, what are the K factors? What are the C factors? So if I'm minimal tilling, what does this look like and how does that work? So what's cool is when they were doing that work in Canada, we were doing that work in the Peace region. So we actually have some K factors that were determined. We have how, like in the C factor, how does tillage practices affect your soil loss per year? So when you look at the bottom of that table that's in here, this is a snapshot of that historical work that was done back in the 80s and 90s with people like Sandra Burton and Keith Carroll, and there's a long list of people who were instrumental. Rob Klein, who worked with the Ministry of Ag. Lots of people were involved in that. And if you look at the very bottom right-hand corner, you can see, you know, in conservation tillage versus reduced tillage versus zero till, you know, what's the soil loss in tons per hectare in terms of what those numbers are. And so you can see some percentages changes in the soil loss in tons per hectare. I think I've got this right. And then, you know, if you were looking at, if you're looking at fallow, so these are kind of the factors of what those numbers would represent. And so I think where it's presented more clearly for you, because this is just a snapshot jumping you into this information, is in our fact sheet number 4. There's and attached in our fact sheet number 4 and attached to this webinar information are all the specific references to this, and so we actually have our local factors in there. So I would encourage you to go look at that if you're wondering what our actual numbers are. That's where you'll find that information. So key messages from this whole concept of managing runoff and erosion is just looking at soil organic matter as one of the key cogs in the wheel of protecting from soil erosion. Crop choice, tillage, and timing are all kind of tied together. Even if you have one really figured out, if you are over tilling or, you know, leading lots of bare ground, you're going to have lots of vulnerabilities to the erosion risk factors. The slope, so the key vulnerabilities for our region, as I'm sure people are aware of, is about slope length, as Sandy had talked about, the spring runoff on frozen soils, which, you know, we can't prevent the spring runoff, but things like strip cropping and timing our tillage events help manage that spring runoff and make it as little impact on soil loss as possible. Soil texture, we're particularly vulnerable to compaction with a lot of our clay soils. So just reminding you, when you're getting on those soils, if you get on them too wet, tire sizing, those types of things make a big difference. And then rejuvenation is a big factor. So for the livestock and the forage seed producers in the room, or the forage producers, how long is that soil bare in the rejuvenation process? And minimizing that as much as you can with the tools that you have available to you. So I think that is kind of the conclusion of our webinar. We've got those fact sheets I had alluded to on the side. Those are links for the RUSLE FAQ and the BC soil maps as tools that you might want to be exploring. And I'm not sure if we have time for questions or how you want to handle that last little bit of time there, Lindsay.
It doesn't seem like we have any additional questions at this time. Perhaps you want to provide some follow-up information if folks have any additional questions for you, and how they can get in touch with you. There's a nice note saying thank you for this. And if not, if folks have additional questions, they could also reach out to AgriService BC if they'd like to speak with a ministry staff person. But do you want to give any kind of contact information or anything like that?
Sure. I think, well, I'll provide a little bit verbally, and then maybe I'll send a quick email over to you with that omission on my part, sorry. And then if there are people wanting to reach out with an email or something, they're certainly welcome to. So I think I'll just provide my contact information, and then if you're trying to reach out to some of the other presenters, I will filter that through rather than making this more complicated than it needs to be. So my contact information is Julie, Julie, at forage, FORAGE, friendly, FRIENDLY.ca. So that's Julie at foragefriendly.ca. And if you're a phone person, which I am, 250-262-7576. That's 262-7576. And that's a text or a phone call. If you just want to know where a resource is or something, feel free to send that over, and I'll pass it on to the right person if that's not me. Thank you for taking the time to join us today.
Great. Thank you so much to the group for delivering today's webinar. If you have further questions, feel free to reach out to us. A reminder to check our AgriService BC website, and that'll provide you information on upcoming webinars and recordings of past webinars. And you can also sign up on the website now to receive updated information on our webinars and workshops and events supported by the Ministry of Agriculture, as well as new resources that we have coming from the ministry. So once again, thank you for joining us, and enjoy the rest of your day.